Hello everybody, I am Connor Thompson and this is my Physics 2211 Lab 1 report. I am a first year double E major and this Lab 1 is all about observing the motion of objects at constant speeds and without changing direction, so this means there's no net force acting on these objects. And we analyze this data through observed means, so we use the tracker program for one, or you can use predicted models, so glow script code and models you can make with that code. This lab primarily deals with concepts of net force, velocity, position, displacement, and the modeling of these concepts with these two programs I just named, and along with the idea of a system versus surroundings. So, for example, our system could be the rolling object, and the surroundings could be the table or the air that this object is rolling through or rolling on that push back against this object through friction. Before we go any further, this is just a quick skim of our results. So this is the glow script code. I'll go through with what these red lines mean here in a bit. And this is a screenshot of the tracker program. So you can see this is like the linear model of our position versus time. You can see it's a little wonky due to possibly errors made by friction or just plotting these points. And then you can see down here the 2-second mark and 0.85 meters. Do remember these because these are pretty important later on in the next coming slides. And then this is just the object itself that was being modeled. This is the glow script model of the actual behavior. This is the same graph as tracker, except it's a lot more linear because this was made with the assumption of no net force, whereas with this one, like I said, there could be some friction acting upon it. And then this is just an Excel graph where this and the tracker graph are combined together. So you can have these orange dots right here that are connected by a line of best fit you can't really see, but it's supposed to pretty much just resemble this one, whereas all these offset blue dots are coming from the tracker graph. And you can still see you have the 0.835 meters here, although it is with a little bit of scientific notation here, and then the 2 seconds here. Now for the background of the experiment, the primary equation we used to develop this model was the equation for velocity. So like I said, we had 0.835 meters and we had 2 seconds. So if you divide 0.835 by 2, you get 0.4175 meters per second. So I put that into the x component here. And then everything with tracker was done in time intervals of 0.033 seconds. So what I did is I multiplied this by 0.033 and I got position intervals of 0.01376. And this was all I really changed in the code, and this allowed us to create a model based on these assumptions that was pretty close to what was given to us by Tracker, and if not, maybe a little bit more accurate because of some of the plotting errors. Now, as for the simulation differences, like I said, there were some plotting errors because with Tracker you had to put down the points manually as the time went on, and so that could create some of these errors, but there also could be some friction that wasn't accounted for um, by the glow script code because, like I said, there's no net force here. That could also make this a little bit skewed. But overall, because these graphs kind of had that same underlying concept of roughly no net force, they were pretty similar, and thus they were pretty much the same graph. And like I said, you can kind of see these inconsistencies back on the Excel graph too, just with how this one's a little wonkier, whereas the glow script one is a lot straighter. Now, for the final part of the lab, there were two extra questions that were asked in the instructions. So, for example, for one, what if we flip the axis? So, for this, we had it in the positive x direction. However, if we were to flip it in the negative x direction, the only things that would really change is we would be moving the object in a negative direction, which means negative position, negative velocity, but the values would be the same in terms of magnitude. So, all we would have is a negative, roughly linear slope instead of a positive, roughly linear slope. That's all that would really change. Furthermore, what does it mean in terms of all the forces acting on this object? Well, going back here, we only have a few forces acting on it. So for one, we have gravity pulling it down, and we also have a normal force by the table pushing it up. These cancel out because they are equal and opposite forces, and outside of the initial applied force to get this object rolling, we only have a little bit of friction possibly pushing it back, but it's so insignificant, and especially over this small time interval, you can essentially attribute the whole object to zero net force, and this assumption allows us to model the behavior of this object pretty accurately with GlowScript code, as there is roughly zero net force. And so if we were to say there's roughly zero net force in GlowScript, we would get a similar model as to the one that was given to us by Track. But essentially, that is everything. That is the conclusion of my Lab 1 results. Thank you for watching.